Visits to the planetarium here in Rochester always amazed me as a child. As the hulking mechanical projector rose up from beneath the floor and began to glow, the flat dark dome of the planetarium was suddenly filled with pinpoints of light, each representing a radiating ball of plasma hundreds of trillions of miles away. As the motors began to whir, the projector spun and we were led on a tour of the observable universe. Planets, stars, constellations, nebulae, and galaxies all filled our virtual sky. The ethereal beauty and titanic scale of these objects was far greater than anything encountered in our limited terrestrial experience. It was the sheer scope of astronomy's domain that drew me and continued to compel me to understand the workings of the universe. As Carl Sagan once put it, the cosmos is all that is, or ever was, or ever will be. The image you see here is one created by the Event Horizon Telescope, and to me it represents a crowning achievement in humanity's scientific quest. It was generated by combining data taken simultaneously through 8 radio telescope arrays spread across the world, spanning from Antarctica to northern Europe. Each of these separate systems simultaneously watched and listened to the distant galaxy M87, which has at its center a black hole more massive than our entire solar system. This is the first time in history that we have been able to peer into a black hole, to see the event horizon and the surrounding disk of gas, superheated and glowing as it is accelerated to velocities near the speed of light. This image gave us the chance to test and further verify Einstein's equations of general relativity, which describe space as a 3-dimensional fabric that can be stretched and compressed by massive objects, like this black hole. This image also gives us the opportunity to glimpse into the strange and unknown world of quantum gravity, increasing the possibility that we may someday understand and be able to harness the full power of quantum physics to our own benefit. When Einstein formulated special and general relativity in the early 1900s, he had no way to predict that it would one day become the key to creating a global network of GPS satellites. These satellites orbit so high above the Earth and travel so fast that they are forced to account for the slowing down of time predicted by special relativity in order to prevent their clocks from losing accuracy, which would render them useless for pinpointing positions on Earth. Just as Einstein in 1915 could not possibly imagine the technological miracles that relativity would make possible, we today cannot begin to fathom the benefits that we may one day reap from an understanding of quantum gravity. This image also speaks to the nature of science itself in the modern world. Our aggregate knowledge as a species has progressed to the point where scientific breakthroughs are rarely the result of a single individual constructing and laboring over an idea or an experiment. Most of the fundamental advancements in physics over the last 20 years, from the detection of the Higgs boson at CERN and gravitational waves at LIGO, to this, the imaging of a black hole with the Event Horizon Telescope, were only possible through the cooperation and contribution of scientists across the world. It would have been both monetarily and physically impossible for a single nation to create this vast array of telescopes spanning half the globe. Science and space exploration have become activities that connect us globally as a species. The International Space Station is perhaps the best demonstration of how science and exploration have advanced unhindered by the quarreling and petty disputes of national governments. The ISS has been continuously occupied for nearly 20 years by astronauts from 18 different countries. Its very construction and operation would not have been possible without the space programs of both the United States and Russia, 2 countries who were, not so long ago, bitter rivals. NASA's space shuttle made it possible to transport many of the large modules that now make up the space station. And after the space shuttle was retired in 2011, U.S. astronauts have only been able to continue their travel to and from the ISS on board Russian Soyuz rockets. Even through rising tensions and military aggression, American astronauts and Russian cosmonauts have worked together peacefully on board this floating laboratory, 200 miles above Earth's surface, where national boundaries become no more than imaginary lines drawn on a map. Very soon, American astronauts will once again launch from Cape Canaveral on a SpaceX rocket, And while this is certainly a technological achievement that will further our ultimate goal of expanding as a species, we must not let this new independence cause us to forget our long history of cooperation. Thinking back to those images that inspired me as a child, I now appreciate not only the beauty of these celestial bodies, but also the international cooperation that made missions like Hubble and Cassini possible. From the prehistoric era, when science meant the control of fire and mastery of farming, to the 21st century, when science means the construction of massive machinery to detect and measure the universe around us, science has always connected us as a species. It has allowed us to influence the world around us, whether positively or negatively, and allowed us to understand the cosmos, both inside ourselves and throughout the universe. Perhaps this image, which to me signifies our cooperation as a species towards the noble goal of understanding, will one day inspire a young child sitting in a planetarium as those other images once did for me.